Welcome back. In this video series we're going to talk about balancing equations. There are two methods to do this. Well, actually there's a lot more than two, but I'm only going to show you two. And the first one is going to be by inspection. Now this whole balancing equation stuff is actually really easy, and I think you're going to get the hang of it pretty quick. Okay? So let's begin. The first thing you're going to do is check for diatomic molecules. Now we've talked about these multiple times in the past. Remember, the saying that we have is anything that ends in gen is diatomic. So that covers hydrogen, nitrogen, oxygen, and all of the halogens, which are these guys right here. Okay, if those elements appear to be by themselves in an equation, then they need to be written with a subscript of 2, as you see up here. You're never going to have just a hydrogen sitting out there by itself. Okay, that is a no-no. Alright, you always need to have that subscript of 2 because it's diatomic. It pairs up with another one of itself. Okay? The next thing that you're going to do to balance by inspection is going to be balance all the atoms other than hydrogen and oxygen first. Then you balance the hydrogen, then you balance the oxygen, and then just to be sure, recount everything and make sure it equals on both sides. Remember, the whole purpose of balancing an equation is to make sure that we are obeying the law of conservation of matter. Alright, you cannot create or destroy matter, so both sides of a chemical equation need to show that they're equal to each other. You will balance equations by adding coefficients and never by changing the subscripts. The subscripts are like carved in stone. You cannot change those. Remember, from our nomenclature, those subscripts are there because we crisscrossed and reduced, or they're there because of the any-outy rule telling us how many oxygens we have to have. So there's a specific reason that those numbers are what they are. You can't change them without changing the compound itself. Okay? If you run into a problem and you've done all of the steps that we just did and it's not balanced, then you're going to work your way back up the steps from bottom to top until you find where it went wrong, and then you fix it. Alright, and then if every coefficient will reduce, then you need to write it in the simplest whole number ratio. If you don't, then you have not given the correct equation. Okay? Now this word coefficient, we actually have talked about it before once upon a time, but just to revisit that, these are the large numbers in front of a molecule, and they multiply everything in that molecule. Alright, let's do some practice questions. Okay, here's the first equation. Potassium plus water makes potassium hydroxide plus hydrogen. And we want to balance. Okay, so here's what I do. Some people will put a line underneath the reaction arrow just to kind of keep both sides separate. I don't prefer doing that, but you can if you want to. What you are going to do is make a list of each of the elements that you come across in the equation in the order that you see them on both sides of the reaction arrow. And you want to write them in the same order on both sides of the arrow. That way you don't get mixed up when you're trying to tally up how many of each element there are. Okay, so now we're going to list how many of each of these elements are on the left hand side and how many of each of them are on the right hand side. So there's 1 potassium on the left and there's 1 potassium on the right. There are 2 hydrogens on the left, and there are 3 hydrogens on the right. We have 1, 2, and then a third one right here. Then we have 1 oxygen on the left, and 1 oxygen on the right. Okay, so now we need to go through our steps. First we check for diatomic molecules. Here's one, and it's been written correctly, so that's good. Then the next thing is we have to balance all the elements besides hydrogen and oxygen first. That would be potassium, and it's already balanced because it's equal on both sides. Then the next one is to balance the hydrogens. Okay, so we need to figure out a coefficient to put here, here, or maybe some combination of those three in order to balance out our hydrogens on the left and right hand side. So kind of a trick of the trade is if you see one of the elements that you're looking for and it's by itself here, and when I say by itself I mean it's not kind of like in a double like over here, but you see that there's just one of them, that is your opportunity to make things become even. When you're balancing, usually odd numbers are kind of the enemy, and you don't see those very often. They do pop up, but not very often. And so if you have an opportunity to get rid of an odd number like we have here and make it an even number, you should take it. So what I notice is if I put a 2 right here, that would give me 2 hydrogens here, and I already have 2 here, which means my total number of hydrogens would raise to 4 down here, and that's an even number. So I'm going to go ahead and do that. Okay, so now I have 4 hydrogens over here and only 2 hydrogens here. So how do I get this to change to 4? I'm going to multiply by 2. Okay, so that takes care of my hydrogens. Now, because I've done that, this 2 actually multiplies everything in the compound. So that gives me 2 oxygens over here, and it gives me 2 oxygens over here. So everything is balanced now on both sides of my chemical equation. So this is balanced. Alright, now one more thing that I want to talk to you about. There are coefficients in front of the K and in front of the H2. They just happen to be 1s. And 1s are understood, just like they were back in nomenclature. Now for the beginning of this balancing equations section, until I give you further notice, you are required to show the understood 1s. And that's so that I know that you understand that they're there. Once I feel like we've all got the hang of it, then I will ditch that and you won't have to do it anymore, okay? So we're going to go in and put our understood 1s in front of our elements and compounds. Okay, let's take a look at the next one here. We're going to do the same thing and list our elements in the order that we see them, in the same exact order on both sides of the reaction arrow. Alright, now we need to make a list of how many of each element we have on the left and right hand side of the reaction arrow. Okay, then we need to check for diatomic molecules. I don't see any. Then we need to balance everything other than hydrogen and oxygen. Okay, there is no hydrogen and oxygen here, so that means we have our pick. We can balance starting with anything we want. Now, the zinc is already balanced and the silver is already balanced, so that kind of dictates that we have to start with chlorine. There are 2 chlorines on the right-hand side and only 1 on the left. So, how do I get 2 chlorines here? Obviously, I'm going to have to multiply by 2. Okay? But when I do that, it changes my silver to 2 also. So, my chlorines are balanced, but now my silvers are not. So if I want there to be 2 silvers on this side, I need to multiply by 2. Okay, so now it looks like both sides are equal. Of course, I have an understood 1 here and an understood 1 here, and you are required to put those in, so let's do that. Okay, and so we have the correct balanced chemical equation. Alright, the next method that we're going to use to balance an equation is by algebra. Now, some people like this method and some people don't, and that's okay. There's nothing in my class that says you have to balance an equation by algebra, and there's nothing that says you have to balance it by inspection. It's whichever one you feel the most comfortable with. Now, I personally like the algebra method better. It's more concrete for me. There's no guesswork. Sometimes, and you'll notice this if you're an inspection person, you'll see that as you're working some of the questions that have a lot of oxygens in them, you'll get trapped in this loop, and every time you change one thing, it'll mess something else up, and when you go fix that, it'll mess up the thing that you had just fixed, and so you get stuck in this never-ending cycle, it seems. That doesn't happen if you do the algebra method. Now, as with anything, there are certain situations when you would want to use the algebra method, and then there may be cases when you don't. That's why I really think it's beneficial for you to know both methods so that you have multiple tools in your tool belt of chemistry. Okay, so if you've got a small problem like this one here, then probably the best method would be to use inspection, because algebra method is a little bit longer. So if you have a big long equation to do, if you start out with algebra, then you would actually probably finish that problem before an inspection person does. But if you have a short problem, the inspection person is going to win. So if you can do both, then you've got the best of both worlds and you'll save some time over the long run. Alright, let's see how we actually do this. We're going to treat this chemical equation just like it's an algebraic equation. And we're going to let this reaction arrow here represent an equal sign. And then we're going to place letter coefficients in front of each term. Okay, now remember, at the end of the problem here, let's say that we had gone through and we balanced everything, there are going to be coefficients in front of each of these compounds and molecules here. Even if the coefficient is a 1, it's still going to be a number there. Now, just like in algebra, when there's a number and you don't know what it is yet, you let a variable take the place of that number until you can figure it out. So we're going to end up with something that looks like this. So I've put an A, a B, and a C in front of my compounds. And those letters are going to represent the answers, the balancing answers at the end. I just don't know what they are yet. Now you can use any letter you want to, but I just go in order and do A, B, C, D, so on and so forth. Okay, now we're going to create an equation for each element in the equation. Okay, and here's how you do it. We're going to write down the symbol for hydrogen. Here I've written the word out, but usually I just put an H down. Okay, and then you're going to take the subscript of that element and multiply it by the variable you have in front. So I'm going to have 2A for hydrogen. Now here in this B term there are no hydrogens, so you can either put plus 0B or you can just not put any B down at all. Then the arrow, remember, is an equal sign, so we're going to put equals. And then here I have hydrogens again, so I'm going to say 2 times C for those 2 hydrogens. Okay? And then you'll do the same thing for oxygen. And those are the only 2 elements in this formula here. There's hydrogen and oxygen. So there are no oxygens in the A term, so we put 0A. You don't even have to have that at all if you don't want. You could just start with this term here. There are 2 oxygens in the B term, so you have 2B, and that equals, you have 1 oxygen in the C term, so that equals 1C, or just C. Okay, now that we have created our 2 equations here, we're just going to use a system of equations to solve it. Okay? You'll notice since we have 2A equals 2C, the 2's can cancel out on both sides, and that just means that A equals C. And then we have 2B equals C. And it says here that that means that B must be equal to 1/2 C. Who cares? We don't even need to know that. Okay? We can just straight up use this equation right here. That's fine. You don't need to go through all that other stuff. Okay, so the next step is you get to choose any number you want, and it needs to be a positive whole number, but any number you want, and it can stand for any letter that you have up there, A, B, or C. Okay? Now usually we choose the number 1, and the smaller the number, the better. But you choose any number you want and set it equal to one of your variables. And it's a good idea, if you can, to try and kill 2 birds with 1 stone. Here's what I mean by that. If you choose letter A or letter C to equal your number, then you've automatically figured out what the other one is, because those 2 are equal to each other. If you choose B, however, then you're only going to be able to find out letter C. So I have chosen in this case to let letter C equal 1. And here's what I usually do. I usually make a list of my letters over to the side. So let's do that. Okay, so we let c equal 1, which means that a automatically equals 1. That's what we have right here. Okay? Now we're going to use this second equation right here, the equation for oxygen, and we're going to solve for letter B because we don't know that yet. So we're going to say 2B equals 1 because right here 2B equals C, and we've said that C equals 1. Now we just need to solve for letter B. So we're going to divide both sides by 2. That means that B is going to equal 1/2. Okay, now we did say that these have to be whole numbers, okay? We can't have any fractions. So let's get rid of that fraction there. The way that we're going to get rid of a fraction is by multiplying by the denominator. And whatever you do to one of your numbers, you have to do to all of them. So I'm going to multiply each of these by 2. Okay? These 2's are going to cancel out and leave a 1 behind. And then here we get a 2, and here we get a 2. Okay? That means that these are our final coefficients for our formula. So you get 2 hydrogens, 1 oxygen, and 2 waters. Okay? So remember, if you have a fraction, you need to cancel out all the fractions by multiplying everything by the denominator. If you get multiple fractions, then just go through a little piece at a time and get rid of one of the fractions and get a new set of numbers, and then multiply by the other fraction's denominator and get rid of that one, and just go through and get rid of all of your fractions. That is really rare that that happens, and it usually happens if you pick a really big number or you pick an odd number. Usually picking a 2 is really good, or picking a 1 can be good as well. Okay, so I've got 3 practice questions for us here that we're going to go through and do the algebra method on. Okay, so the first thing that we're going to do is to change this arrow into an equal sign and put our A, B, and C here. Okay, the next thing we need to do is to write our equation for each of our elements. So let's start by listing our elements first, and then we can come up with the equations together. Okay, we have 8 sulfurs in this A term, so we're going to write 8A. There are no sulfurs in the B term, so we're going to skip that and bring our equal sign down. And then we have 1 sulfur in the C term, so we're going to write C. Okay, now let's go back and do oxygen's equation. There are no oxygens in the A term, so we're going to skip it, and we're going to start with the B term. We have 2 oxygens in the B term, so we'll write down 2B. Then we're going to bring down our equal sign, and then we have 2 oxygens in the C term, so we'll write 2C. Okay, so now we have our equation for sulfur and we have our equation for oxygen. You'll notice that the 2's in oxygen's equation cancel out, and that means that B equals C. Okay, the next thing we're going to do is list our variables over here along the side and pick a number to equal one of our variables. Okay, so here's our list of variables, and I've decided to let B equal 1. The reason I did that is because I can kill 2 birds with 1 stone by doing that. As soon as I know what B is, I automatically know what C is. So we can cross this equation out because we've used it. So now all we have to do is figure out what letter A equals. We know that C equals 1, so we're going to plug that in. We've got 8A equals 1. We're going to divide both sides by 8, and that means that A has to equal 1/8. Okay, now all we have to do is get rid of that fraction, and we'll do that by multiplying everything by the denominator. So we multiply each of these by 8. So here, 1 times 8 is 8. Again, 1 times 8 is 8. And here, the 8's cancel out and leave a 1 behind. So that's our final answer then. These are the coefficients. So we're going to go back up to our equation here and put them in. Okay? Now, again, we are just getting practice here. If you had a formula this small, that simple, you would probably choose to use inspection to figure it out. We are just practicing how to do the algebra method now. If you had something like this, on the other hand, you might lean towards the algebra method rather than the inspection because it's quite a bit larger. It's got more elements that you have to track all of the values for. So let's go ahead, get rid of this arrow, make it an equal sign, and put our variables into that equation. Alright, now we're going to come up with an equation for each of the elements. So we need one for potassium, oxygen, hydrogen, and phosphorus. I want you to try and come up with those on your own. Get out some paper or something and write those down, come up with the equations, and then we'll come back in just a second and see if you got what I got. Okay, here's what we've come up with. So now we're going to make a list of our variables over here on the side. Okay, and then I see here that B is the same as C, so I'm going to choose one of those to equal my number. So I've chosen to let B equal 2 this time. And so I'm going to use this equation, and since B equals C, then that means I can put a 2 here. So this equation gets crossed out, and we'll put a 2 in for C. Okay, so now we have 3 equations left to choose from. Obviously, we should probably pick the simplest one to do first. So we're going to choose A equals 3C. Now, let's see here. We've got A equals 3 times. Now, C, we've said, is equal to 2, so we're going to put a 2 here. Well, 3 times 2 is 6. That means A must equal 6. Alright, so this equation's done. And now we have 2 equations left to choose from. We want to find an equation that has the letter D in it, because that's the only thing we have left to figure out. And the simpler the better. That means this one would probably be the best equation to find. So let's see. A is equal to 6 plus 3 times B, we've said, is 2. So it'll be 3 times 2 here. And all of that equals 2 times D. Okay, well, 3 times 2 is 6. So we're going to have 6 plus 6 equals 2D. 6 plus 6 is 12. So we're going to have 12 equals 2D. And then we'll divide both sides by 2. Therefore, D must be equal to 6. Okay, it would seem as though we're done. See, all of these are positive and they're whole numbers. However, we do need to recognize that these things can divide evenly into each other. Okay, everything here can be divided by 2. And so we really have to do that in order to get this question right. So here is our final answer for our coefficients. So we're just going to come in and put those here in place of our letters. Okay? So let's try one more question and then we'll be done. Okay? So we have this equation, and this time I'm not going to walk through it with you. I'm going to let you figure it all out on your own, and then we'll come back and see if you got what I got in just a minute, okay? Okay, so here are the equations for each of the elements. We have 2A equals C for iron. We have 3A plus B for oxygen equals 2D. And then for carbon, we have B equals D. Right? I chose to let B equal 2, and then that meant that D equaled 2. So this equation is done. Then I plugged into this equation so I could figure out what letter A is. So we said 3A plus 2, because we just said that letter B equals 2, is equal to 2 times d. Well, if d equals 2, then 2 times d must be 4. So I subtract 2 from both sides, which means 3a equals 2. Divide 3 on both sides, and a must be 2/3. So that got plugged in up here. This equation is now done. Now we got to find out what c is. So we said 2 times 2/3, because that's what a equals, is equal to c. That means that c is equal to 4/3, and so that's what got put right here. Now we have to get rid of those fractions, so we're going to multiply by the denominator. So everything gets multiplied through by 3, which means a 2 gets left behind here. This is equal to 6. A 4 gets left behind here, and this is equal to 6. That means that we had 2, 6, 4, 6. All of those numbers are divisible by 2, so we have to divide everything by 2. That means we have 1, 3, 2, 3 as our final answer. Okay, so this one was a little bit more complex. I hope that you made it through. The only reason that I had to do this kind of double thing here is because I chose a 2. You know, if I had chosen a 3 for letter B, the thing that it actually turned out to be, then maybe everything would have been much simpler. Who knows? But ultimately, that really wasn't too terribly difficult. We just got rid of the fractions, which we've already done once in a previous problem, and we had to simplify into smaller whole number ratios, which we did in the other practice problem. So this one just kind of combined both of our new skills. Alright, if you have any other questions about the algebra method or the inspection method, make sure and come by and see me for tutorials. And as always, thanks for learning with me. Bye.